Hello everyone, my name is Jonathan Crellin and I'm going to show you something about how a tool called aircrack-ng actually works. So aircrack-ng was originally designed as a command line tool for Linux, but we can use it in other operating systems. So I'm going to show you how you can use it in the Mac OS. Now, the purpose of this tool is to crack keys used to log on to wireless routers. So typically it was actually designed way back at the beginning of the century to crack WEP passwords. And it could still do that, except there are virtually no WEP encryption used on modern routers at all. So it actually still also works with WPA and WPA2, where we're using a shared key. So this is PSK. So we can use it to recover that shared password, which is of course the one when your friend comes around and says, oh, can I use your Wi-Fi? You give him that password. So it's a password that everybody uses to access the router. One thing I should say is that you should try this out. It's interesting to see how it works, and if you can get it working, it's good. It shows you have the sort of right mindset to become a security analyst. But the important thing to bear in mind is that it is potentially illegal to attempt to crack a router that doesn't belong to you. So you should always use your own equipment. And in this test, what I'm doing is showing you using my own router, which I preset with a very easy password. So hopefully we'll get the results fairly quickly. So let's go ahead and have a look at aircrack-ng. So okay, here we've got a man page for aircrack-ng. It shows the basic type the command, and then you have some options potentially, and then you type an input file. So the thing it needs to do is actually work on capture file. This is the description of the things it can use. A capture file that captures the packets of data as they're being transmitted by the iPad or the iPhone to the router. So that capture file is something that you can use a number of different tools to create, but in particular we're going to use one that's actually built into the macOS operating system, which is called Airport. It's actually hidden away, so it's quite difficult to find. I'll show you that in a little while. Now, options, well, there actually are many. I mean, for example, one of the common ones would be A mode, so it's A and then 1 or 2, and that basically forces it into either WEP only or WPA only. Another one that you might well find yourself using is this one, the E -E option, which is basically the ESSID, which is selecting a target network based on its name. And so in this case, you have to put the name of the wireless network into a bracket. Sometimes the capture files don't actually manage to identify the name because it might be cloaked. You can also use the BSSID, which is actually the MAC address of the type. Now, other ones are quite useful. Let's go down a long way down, and then we will find them. Is this? So when you're cracking a WPA password, you need a dictionary. So it won't be able to identify things or passwords that aren't in the dictionary. So you will need a large dictionary text file that contains all the potential passwords separated by space. So you can find these fairly easily. There's plenty of these around, and one of the common ones is one called RockU. Now, the RockU dictionary was actually based on a breach that happened in 2009 of a company called RockU, and they did things like make artifacts, applications for MySpace, etc., and many other things. And part of the when you signed up for that service from RockU, records of your passwords for different services. They were breached in 2009. They didn't admit to it, and 32 million sets of credentials were stolen. So actually what we have here is RockU. It's actually RockU.txt. It's about 130 megabytes in size of text file. You can see it's quite big. It contains roughly 10,000 passwords, and you can use that as a basis. However, you may want to use other techniques to actually target your password. Of course, the other thing about RockU is it will be best for American sites or English-speaking sites rather than sites in other countries. If you want to find password files for other countries, you can do that. You can even generate them fairly easily. And I'll show you about that a little bit later on in this session. Okay, I'll just finish with that for a moment, and then we'll carry on with the rest. Hello everyone again. I've already shown you something about how the dictionaries work. Now let's have a look at how we can actually capture files that we can then convert with aircrack-ng and hopefully recover some passwords. So obviously I'm going to be using my own equipment, so I'm using a router that belongs to me, as I'll show you next. So when we go over to the router that belongs to me, first off, we need to actually identify some of the tools. So first off, I'm going to show you the tool that we have to use for actually capturing packets from the router. So this is actually situated in a very obscure place. So it's /system/library/private frameworks/apple 802.11.framework/versions/current/resources. So I'll put that into the notes, and you should be able to paste it straight in and move there in the command line. So inside this directory, we have a number of files. We have a couple of property lists, which Apple always uses a lot of, and mobile applications too. P-lists, and we also have a couple of other files. Now, the one we're interested in is the one that says airport. So airport is in fact an executable, a binary, and we can actually use that to actually execute commands. You can see it's an executable here by the listing here. So what we're going to do then, first of all, is to have a look at what's around. We're going to get a view of the local Wi-Fi environment. So we're going to kind of spy into that. Now, I did all of these commands earlier on, so I've got them in a long list. So I'm just typing the up key. But first thing to know about this, it's got to be sudo. It's got to be run as root. And because we're in a directory that isn't part of the standard path, we're having to use / to say run the application that you found here, not in the standard path. And then we're also using the -s switch in order to tell it to give us a view of the what's around in the wireless network. Now, it doesn't always work first off. Of course, it's sudo, so first thing I have to do is type in my password. And then it's worked. And basically what it's done is it's given us the SSID, or sometimes known as the ESSID, which is the name of the network as it appears to users when they're looking for networks to join. You can see there are two channels or two potentially connectable wireless points, access points here. Next, it gives us the BSSID, which is actually the hardware address. It's the MAC address of the router card. And we can see the two MAC addresses here. They're both the same. And the reason for that is, of course, both of these channels are contained within a single router. So its external MAC address is going to be the same in both instances. You can see that each of these has a different channel. You can probably tell that this one is going to be a 5G channel, which probably implies that this one is a 2.5G channel. I know it is because these are this is my router. And of course, you can also see something about the security. So first off, they're both using WPA2, and they're using shared key access. So public shared key access. So that means that everybody uses the same password or the key to actually log on to these devices. Now, what we need to do next is to actually capture some packets. So because we don't have aircrack-ng, which is part of the aircrack suite of applications, we have to use the airport application to pick up that traffic. So we need to type another command in here to get this to work, and this is the one that we have to type in. So again, sudo, again, period slash, the name of the application, but this time we have to give it different arguments. So N0 is in fact the wireless card in a Mac. Now normally the first wireless card would be an Ethernet card, and that would be N0, and the second one would be a Wi-Fi card. But a lot of modern Macs don't actually have an Ethernet port anymore, so that means the wireless card becomes N0. We also have to issue the sniff command, and we have to tell it which channel we're going to actually capture data from. And so once we've done that, we just run it, and it starts capturing frames. So each of these frames will be useful for us for doing our encryption later on. So we can run that for a while. Now, one of the things that we know about WPA capture is that it doesn't really capture anything useful from the data packets, but it does capture information from the authentication of, or essentially when a device joins that particular wireless network. So what we're actually going to try to do, or we should try to do, is to actually make that happen as often as possible. Now I can do it on this simply by taking my device and going to the wireless Wi-Fi screen and just turning the Wi-Fi off and then on again and waiting until it reconnects to the right network. And I could do that over and over again. But that kind of defeats the purpose, doesn't it? Because that means I can find out the password for the router that I already know, I already have a device that's connected to. So there is another mechanism called deauthing. Now the only problem is it's quite difficult to do this on the Mac as we're collecting data. So if we try to run the application that will do that on the Mac, there is a GUI application that will do that. It's called Jam Wi-Fi. And it has a simple screen. It also asks for a password because it's doing things at a high level. But whilst we're actually running a capture, I think we'll find that it, yeah, there we go. Whilst we're running a capture, when we try to scan, it can't do it because basically this device has taken control of the network. So what I'm going to do at this point is just cancel this, and we probably have to run this for a long time and hope there was a lot of joining and leaving on this Wi-Fi network in order for it to work. So it might work, for example, where you have a public Wi-Fi that has a standard address like a cafe or a restaurant or something, and then you'd be able to pick up the data fairly easily from there. So we'll stop that running now. And you can see a useful thing is the address or the name of the capture file that's been generated, and it's usually generated into the temp directory, which in Unix is usually used for short-term files, and it's periodically cleared. And in fact, now if we scan on this one, we should find it works. Yep, there we go, and we can see the two wireless networks, as we could see with the other system. We can see the same MAC address information, and we can see something about the security methods. Now, on this system, we can actually monitor, and that should mean, yeah, we get a list of the devices that are actually connected. And so we can see here 2 devices, 3 devices. There's probably going to be another few coming through in a minute. Now each of these are ticked, and we can actually deauth them as we want. And so by repeatedly deauthing them, Go to monitor and deauth. Mix up them again as they rejoin. We can actually see those deauths taking place. And they would create the four-way handshake that would actually give us the system. But ideally, we'd like to do it at the same time as we're capturing files. So that's our kind of weakness within the pack framework. In Linux, you can do it at the same time. So, okay, let's go and see if we can find something. Now, I actually have one that I used earlier. So I use, in this case, aircrack-ng command. I give it the address of the capture file I'm going to look at. Notice it's not the same as this one, because this one I know works because I was deauthing manually before during the capture. I also have to give it, using the W switch, an address path to the directory. So I'm using the RockU dictionary. RockU dictionary has 10 million passwords in. It didn't happen to have the right one for my router, so I added it near the beginning. So it can take you 3 hours for it to go through the long list of the 10 million passwords. So if you've been at it for a couple of hours, you probably know you're not actually going to get a response from it. So one of the problems is actually constructing dictionary files, password dictionary files that are going to be useful. You also need to give it the ESSID of the, that is the visible name, human readable visible name of the Wi-Fi router. And this is what we see as LAN B. And because LAN B includes a space, we have to put it into quotes. So if we run this, it'll probably run quite quickly. What I might do is just take out the last two arguments and show you what it's like without those pieces in there. And then you can see what you normally get from a scan. It takes a little while because it's reading quite a few packets. So this is a basic, the minimum amount of information, a single argument for the aircrack.ng file. And as we wait, what we will eventually see will be a list of all the packets that it's received and processed, and the ones that it's identified that might have potential data that we could use inside. And whilst we're doing that, we can go back and have a look at Jam Wi-Fi and see what it's doing. Oh yes, there we go. And so you can see here, for example, what it's done is gone through all of these and has actually highlighted, for example, WPA handshakes. Let's see, D8, WPA handshakes again, WPA handshakes. It's identified some web interaction as well. I'm not sure what drives that. You can see in one case it's actually located the ESSID as well. So it asks us for the target number, so typically 1 in, and then it will tell us that it basically can't do much more with this because it doesn't have all the information it needs. Yeah, so one potential target, but it needs a dictionary in order to work. And in fact, if we put the dictionary in, it'll then tell us that it needs the ESSID. So let's try again, but this time we're going to put in the longer version of the command. So this is the one with the dictionary list in and the ESSID. And hopefully this time it'll work and it'll actually give us a password. Ah, very quick. So key found, yay, 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 yay. And of course, you can see it's a very difficult password, which happened not to be in rocku.txt as well. So I had to add it in manually, and I put it near the beginning, so it didn't take too long. So you could see it was predicting 3 hours in order to actually do the whole of the rocku type password file. So that's basically it. You see how that works, and let's move back to the other screen, and it gives you an idea about what's going on. So you can see how aircrack-ng, even in a Macintosh, can work quite well. One good thing about it is you can use it with the standard built-in Wi-Fi card. You don't need to get something like this, which is an external Wi-Fi card on a tiny stick. So that is a blessing, but you can see you may also have problems with the deauthing options within it, because you actually can't do deauthing whilst you're doing scanning, which is a bit of a pain. So hope that was interesting. And in the other videos, I'll look at using the same operations with all the standard aircrack-ng tools, and we'll be using, in this case, one of the sort of external Wi-Fi cards to make it work. Thank you. Bye.